equation somewhere, or justify that those two numbers will be the same. Eventually they will be the same, okay? And certainly in thermodynamics theory we've got nice little cute formulas that will tell you exactly how many seconds it will take. But here's the story. If you take a piece of hot gold and put into that water, and you sit there and swirl it about, in a few seconds, I don't know how long, 15 seconds, 20 seconds, here's what's going to happen. The gold temperature is going to be way up here, right? The water temperature will be here, and they will come together until they what? Meet. And that is called a state of thermal equilibrium. So once this system has a thermal equilibrium, would you think that both the temperature of the metal and the water would be the same? Yes, and that's true. All right, so here's what we got. We got the final temperature of the gold will equal the final temperature of the water, and that equals the final temperature of the whole entire mixture at thermal equilibrium. All right? At thermal equilibrium. Now we are going to do all of our calculations when there's an equilibrium present, right? We're not going to do any non-standard state equilibrium, non-steady state, none of this. All at thermal equilibrium. Okay, so what does that mean? That means let's just call everything listed there in that string X. Okay, I'm happy. The reason I'm happy is because I got myself one variable now. I mean, it's in two places, or whatever. I got myself one variable. So how am I going to solve this big boy? Well, I'm going to take negative times 325 times 0.131, multiply all that together, right? And then what am I going to do? Distribute. Are you with me? Do you remember distribution from your algebra, right? By the way, the chemistry department's job, it's done. We're done. Now it's the math department's job figuring out how to solve this. So we're going to multiply these together, which is negative 325 times 0.131. That's going to be negative 42.575 plus, what's that next intermediate there? Has anybody got it? What'd you get? Do you get the same things, or I get a second on this? All right. I don't even own the solutions manual, right? I mean, like I know this, so let me get some seconds when you get with me. All right, I got two people. So I guess as long as two people buys my load, that we're good to go. All right, so now I'm going to do the same thing here. I'm going to take 200 times the specific heat of water. Uh-oh, I forgot an X. All right, that'd have been a problem later. 200 times 4.184 is going to be 836.8 X, right? Because you have to distribute that value in. Because there's parentheses there. I have to distribute. Times a negative 22, so that's going to be a negative 18409.6. And let me get you caught up, and let me get a couple of people giving me their head shake before I move along. Sanders giving me a head shake, so I'm good to go, right? How about you, Bonnie?
We're good.
Wonderful. Okay, John, how we doing?
Good.
Perfect. What are we going to do next? Anybody got an idea? What do you want to do?
Put the X's over, take the 836 and put over the other side.
Okay. He wants to take the 836 and put to the other side. In other words, he's calling this combine your like terms, King, right? So here's what we're going to do. Negative 836.8x. So will this cancel?
Yep.
Talk to me, people. Yep, that's gone. Over here, negative 836.8x. So here we go now, negative a 42.575 minus 836.8 will be a negative 879.375x. Now what do you want to do here? You're going to take that non-x term over there? Yeah, okay, what are we going to do? Negative 18179.525 cancels. Negative 18179.525. So here we go. Negative 18179.525 minus 18409.6. Negative 36,589.125. Let me stop there and see if I get some head shaking. You see, anytime in science, people, contrary to what people think, is you got to have help. All right. It happens so many times that the people in the lab next to you, the guy next door, you're very good friends, the girl next door, whoever, you're very good friends with these people. And you take a load of stuff over there for coffee, and you sit down and play solitaire on their computer while they review your calculations, right? And then you have to return the favor because you want to be sure that all the negative signs and everything's figured out. Okay, are we doing good? Okay, what kind of bright idea do you want to do now? Divide by negative 879.375. Okay, what are you getting when you do that? Let's get up here. 41 point what? 6? Okay, 41.6 degrees centigrade. Now, does that make sense to you? What does that, first off, X means nothing, right? Only in math departments does X mean something. What is X? Well, you have to go back up here and find out what it is. It's the final temperature of the gold. Well, I don't care about that, right? But it's the final temperature of the water. Now that I care about, 41.6 degrees centigrade. Is that making sense to you? Look here. Initially it was 22 degrees. It's heated up to 41.6. You may not know if that's the right answer, but it is in the right direction. Yeah, naturally. Now, if it was negative 42, what would have happened? Well, you've done something wrong up in here. But please do not go home happy. I stress that so much. You need to be sure your answer is reasonable. I remember last semester it happened. I remember the girl. She got the wrong answer to the problem but got full credit. You say, well, how can you get full credit with the wrong answer? Well, she had most everything right. She missed one negative sign. Now the girl sitting next to her got a 3-point deduction. This girl got the full credit. You want to know what the difference was? This girl told me, Dr. King, I'm running out of time. Something is the matter. This is not right. All right? See, she had the gumption to understand that the water's not going to freeze when you add hot metal to it. All right? The other person just didn't went home happy. Those things matter. All right? In science, that matters a lot. Okay, have we answered the question? What does the question ask for? What? Calculate the final temperature of the mixture. Is that what this is? Yep. Right, we got it right there. So that's good. 41.6. Was that cute? Did you like that?
Yeah, I want to do a lot of those.
Do you? Wonderful. Well, maybe we won't do a lot, but what do you say you do one? All right. I'll leave this one on the board to use as kind of a running example. Try number 22, right?